Here's another example of how to calculate medication dosages using dimensional analysis. So as always, let's look at the order first. So our order is to titrate 2 to 10 micrograms per kilo per minute to achieve a systolic blood pressure greater than 90 millimeters of mercury. So this is our order. So we're going to give the patient this dosage range until they are achieving this blood pressure right here. Available in our actual bag, the concentration is 400 milligrams per 250 milliliters, and our patient's weight is 180 pounds. So already I know that I'm dealing with a lot of dimensions here because I have pounds that I know I have to convert into kilos. We have minutes that I know we'll have to convert into hours for our milliliter per hour rate. And then also I have micrograms here and milligrams here. So I already know that you have to use the different dimensions here, the different ratios of how milligrams and micrograms and minutes and hours relate. But as always, we start by what we're looking for. And dopamine will always be running on a pump, and a pump is always regulated in milliliters per hour. So that's what we're looking for, milliliters per hour. We'll start with what we're looking for and we say equals. Then we look at in our whole problem, do I have anything that says milliliters, because that's what I'm eventually looking for, and yes I do. I have my dopamine here at the 400 milligrams per 250 milliliters, but because it's in the numerator here, I have to put the 250 in the numerator over here. 250 milliliters per 400 milligrams. Now next, I basically need to eventually cancel out these milligrams, but I don't have any milligrams given here. The only thing I have is the micrograms, but I already know that my relationship from micrograms to milligrams is 1,000 milligrams equals 1,000 micrograms equals 1 milligram. Now I want to eventually be able to cross cancel, so I put 1 milligram is 1,000 microgram. Now the next I should see if I have something that has micrograms in there, and guess what? I do have the 2 to 10, and I recommend doing one calculation with the higher range and then one separate one with the lower range to make sure you're getting that range accurately and at the right decimal. So now I have micrograms here, so I will write 2 micrograms per kilo per minute. Now, do I have anything here in my problem that says kilograms? No, I don't, but I have pounds, and I know the ratio from kilogram is 1 kilogram to 2.2 pounds. And I always write the pound sign like this, because if I write LBS, I could mistake this L as a 1, and then I would have a problem with that. So I always write it as the pounds. And then our patient weighs 180 pounds. And the weight can always go over 1. And so then is there anything else we need to do? Yes, I'm looking for hours, but I have minutes here. So now I need to extend my relationship of 60 minutes and 1 hour. So now I can cross cancel and see whatever units I have on the bottom and on the top, making sure that all I'm left with is the milliliters per hour. So I have milligrams here, milligrams there, micrograms here, micrograms there, kilo, minute, and minute. And then I also have the pounds and the pounds. So the only units I have left over now are my milliliters and my hour, which is exactly what I'm looking for here. And then what I'm left with is just to do the math here, multiply everything on the top, multiply everything on the bottom, and that comes out to be 12.27, and we always round to 1 decimal place, so that will be 12.3 milliliters per hour. So that would be the lower end of our titration here. So now I have to go in and do the same thing with the upper end, with the 10 micrograms. So I again do milliliters per hour because that's what I'm looking for. And I start with my milliliters in the numerator per my 400 milligrams. Then I do my conversion from milligrams to micrograms. Then I go now to the upper end, so now I have to use the 10 here, micrograms per kilo per minute. I have 1 kilo per 2.2 pounds. The patient weighs 180 pounds over 1, and then I have 60 minutes per hour. And then again, I cross cancel milligrams, milligrams, micrograms, micrograms, kilogram, kilogram, minute, minute, pound, pound. What am I left with? Hour on the bottom, milliliter on the top, which is what I'm looking for. And this comes out to be 61.36, which is 61.4 milliliters per hour. So now the pump needs to be adjusted between these 12.3 milliliters per hour and 61.4 milliliters per hour to correspond with the 2 to 10 micrograms per kilo per minute. The other thing that you can kind of use to double check yourself, 2 multiplied by 5 gives us 10. And so if we've done all the ratios here the same, then this 12.3 multiplied by 5 should come out to 61.4, and guess what? It does. What I do not recommend is figuring out this ratio first and then calculating the first number from the lower end of the titration and then just multiplying it by 5, because you can see we have multiple dimensions set up here and there's a lot of room for error. So now if these two don't match, then I would just have to go back and recalculate, make sure I did everything correctly the first time. So please go ahead and check my video on dimensional analysis where I go into all the details and many more examples on YouTube. Thanks for watching.